Today we are solving LeetCode 19, remove nth node from end of list. We are given a linked list. We need to remove the node that is n positions from the end. We cannot directly index into a linked list, so we need to be clever about how we find that node. One approach is to traverse the entire list first, count the total number of nodes, then calculate which node to remove from the front, but that requires 2 passes. Can we do it in 1 pass? Here is the key insight. Imagine 2 pointers moving through the list at the same speed. If one pointer is always n steps ahead of the other, they maintain that gap forever. When the front pointer reaches the end, the back pointer is exactly n steps from the end. But we do not just want to find the nth node, we want to remove it. To remove a node in a linked list, you need its previous node. So we need the back pointer to land 1 step before the target. That means we need the back pointer at the n+1th node from the end. To achieve that, we move the front pointer n+1 steps ahead instead of n. Let us trace through an example. The list is 1, 2, 3, 4, 5, 6. We want to remove the third node from the end, which is node 4. Both pointers start at node 1. We move the front pointer n+1 steps ahead. N is 3, so we move it 4 steps. Front is now at node 5. Back is still at node 1. The gap between them is 4. Now we move both pointers together until front reaches none. Step 1. Front moves to node 6. Back moves to node 2. Step 2. Front moves to none. Back moves to node 3. Back is now at node 3. Node 3 next is node 4, the node we want to remove. Removal is a single line. We set back dot next back dot next dot next. That skips over node 4 entirely. Node 4 is now unreachable. There is one edge case to handle. What if the node to remove is the head itself? In that case, when we try to move the front pointer n+1 steps, it falls off the list and becomes none. We detect this mid-loop. If front becomes none before we finish stepping, we simply return head.next. That removes the head cleanly. One subtle thing worth noting, in the actual code, we only move the front pointer n steps, not n+1. This still works because the while loop condition checks second.next, not second. The loop stops 1 step early. That effectively gives us the same n+1 gap without explicitly coding it. Let us look at the final code. Both pointers start at head. We move the front pointer n steps forward. If it becomes none during this, we return head.next, the edge case. Then we march both pointers until front.next is none. Finally, we set first.next to first.next.next. We return head. Here is the transferable principle from this problem. When you need a specific position from the end of a linked list, use 2 pointers with a fixed gap. The gap determines where the back pointer lands when the front hits the end. Adjust the gap by 1 depending on whether you need the target node or its predecessor.